Doesn't matter what order you write the three ordered pairs down. You're going to put the three ordered pairs down. To do a determinant, it has to be a square matrix, so you have to fill in the last column with ones. So we have that 3 by 3 matrix. The other thing we're going to talk about, and this in the front, this plus or minus 1/2. So we're going to get the determinant. Whatever that answer is, we're going to do half of it. And the reason the plus or minus is on it is because remember, area should always be a positive final answer. But you saw yesterday, I mean, clearly when you do determinants, you could get a negative. So the plus or minus is just on there because it's like, hey, you need to put whatever sign on it in order to turn your final answer to a positive. Area, always positive. Okay, so let's do one. Find the area of the triangle, the vertices, you can see them there. Super easy. So plus or minus 1/2. Determinant. Doesn't matter the order you write the points down. I just do them in the order they give them to you. So 1, 0, 2, 2, 4, 3. And then you have to know, because to do a determinant, it has to be a square matrix. You have to fill these in with ones. So that's one of the tricks. Now, like I said, we're going to kind of mix and match today. I'm going to do the first couple determinants just by hand to review, but then as we get going, we'll probably do a lot of them in our calculator. Okay, so by hand, we're going to repeat the first two columns. So 1, 2, 4, 0, 2, and 3. And remember, you start in the top left corner and multiply your diagonals down. So 1 times 2 times 1. Start at 0, I like a 0. And then 1 times 2 times 3. I'm going to total that up. Now you start in the bottom left corner at the 4, multiply your way up. 4 times 2 times 1, 3 times 1 times 1. I see a 0 in this diagonal, always makes my life easy. So we end up with 11 up there. Okay, so what is your determinant answer? 3 or negative 3? Negative 3, because you would do 8 minus 11, negative 3. Now, to get the area of the triangle, the final answer, plus or minus, we're going to do 1/2 negative 3. Now, yes, I know a fraction, God forbid, but that's not a big deal. You can do it in your head. What's half of 3? 1.5. Now, I'm not going to get crazy about, oh gosh, which sign am I going to write down? I just know the final answer is positive. And I'm going to, I can't help myself. I'm going to throw a label on. Units squared. So the plus or minus is on here because technically I used the negative, so I had a double negative to convert it to a positive. I don't get carried away with that. I just know on an area, always area, my final answers are positive. So I just make it positive. Okay. All right. Next picture looks a little different. We're still going to be able to do our triangle. We have I love it, it's like geometry today, a parallelogram. Remember all that good? The look on your faces is great. So parallelogram, I love it, really is two congruent triangles. So what I'm going to do is I'm just going to split it. I'm going to split it right here. So you can see you have two congruent triangles now. So what I'm going to do, I'm just going to do the area of the left triangle, and I'm going to copy it down for the right one, and I'll add them together for my total overall answer. So I'm going to do the left one. So plus or minus 1/2. So I'm doing these left points. Doesn't matter the order you jot them down in. We just need them all, obviously. So I'm going to do -8, -3, -4, 4. And then my third one right here, 2, 1. Now, we have to know it needs to be square, so we have to fill in the ones. A lot of the application problems are on the graphing calculator part of your test. So, hey, let's do the determinant on this sucker in our graphing calculators, just to practice. We gotta be able to do both, right? So, back into our matrix menu. I'm just gonna slide my calculator over a little bit. It's covering up my problem. Of course, it's a 3 by 3. I'm going to do minus A. And again, I'm not going to bore you with typing them all in today. I'm just going to kind of do the first couple here to review. -8. All right, and I'm always worried I have a typo on this thing because I hate typing on it. Let me just look at it quick. All right, looks good. Remember, once you have it all typed in, you have to quit out. Bless you. Back into your matrix menu. Anytime you need any calculations, you right arrow to math, and clearly number 1's determinate. And I got to tell it of which matrix. Mine was A. So negative 54. So plus or minus 1/2, negative 54. So what's your area of the triangle then? Positive, what's half of 54? 27. Now, not my final answer, because that's the area of this guy we just found. So remember, geometry, parallelogram, 2 congruent triangles. So your other one, 27. So what is the overall area of the parallelogram? 27, 27, 54. So even though we technically did the area of a parallelogram, we used the triangle formula. We just cut it into 2 congruent triangles and copied our answer down. One last problem about triangles. Ready? Little different, but same formula. So find x such that the triangle has an area. Ooh, they're telling you the area. And they give you the vertices. So you can see one of the coordinates there, the last one, we don't know. That's what we have to try to figure out. So different setup, a little more algebra in this guy. So your area is 4. I know that's what I'm supposed to equal, plus or minus 1/2. Okay, again, doesn't matter the order you write the points down. I just do them, obviously, in the order they give them to me. Negative 5, 1, 0, 2. And then we've got negative 2x. Now, we have to make it a square matrix, so we are filling in that column of 1s. Okay. Question for you. Can you do this determinant in your calculator? We don't, that x in there is going to be a problem. Your calculator is going to get cranky about that. Your calculator will only do it if there's all numbers. So I have to do this one by hand. This is probably the last one I'm going to do by hand today. So because of the variable in it, I got to go old school. So I'm going to repeat the first 2 columns. And it's going to look a little weird because we're not going to have just a nice number answer. We're going to have something with x in it. Same process, start in the top left, multiply down your diagonals. So negative 10. 1 times 1 times negative 2. And then, of course, I've got the 0 here. So that wasn't a big deal. Okay, start in the bottom left corner, multiply up. Negative 4. Okay, don't let this throw you off. X times 1, x times negative 5. Got it. And then 1 and the 0. So I cannot combine the negative 4 and the 5x. They're not like terms. Now, when we do our determinant on this, remember, it's your first bottom total, the negative 12, minus your top total, which is that weirdo negative 4 minus 5x. Well, I'm going to simplify that. I'm going to run the negative through. I'm going to combine some like terms because we're really going to have a plus 4 there. So we can put that together, which I'm going to do in a minute, and a plus 5x. So I'm going to combine that, of course, to negative 8. So here's where we're at. We've got ourselves a very lovely algebraic equation. I've got the 4, the 1/2, and for my determinant answer, I've got negative 8 plus 5x. Bless you. So the problem, or the fun part on this one, is we now have to solve this equation for x. The plus or minus on there is going to give you how many answers? 2. I'll tell you this. I can't say as I want to distribute the half through, just because half of 5 is going to be a fraction. Let's clear the half. What gets rid of 1/2 if you multiply by what? Yeah. So I'm going to make this 8, plus or minus, half is out. So we're going to end up, we're going to do a lot of algebra on this one. It's just time consuming. So we're going to get 2 answers. First equation, I'm going to use the positive, which really the positive doesn't change anything, doesn't affect anything. So I'm just going to solve 8 equals negative 8 plus 5x. We'll solve that in a sec. You will get a fraction. Your second answer. So for this one, now I am going to write down the negative. And of course, I'm going to run the negative through, I'm going to switch the signs, etc. So now I'm just going through and solving these two equations and getting our two answers for x. So if I add 8 over, I'm just going to scroll this up a little bit because I feel like I'm getting way at the bottom here. So we're going to get 16 over 5. I'm going to solve this. I'm going to distribute this negative through here. So I'm going to end up with positive 8 minus 5x. Subtract 8 off. So what's your second answer? 0. This is the worst thing you have today. Just because you have to go through and do that determinant by hand. You've got the variable. You got to solve the two equations. Worst thing you got to do today. Overall, is it complicated? No, it's just time consuming. Any questions on that, guy? Okay, backside's super easy. The rest of it's a lot of calculations. So really, we've reviewed how to do determinants by hand. I'm probably not going to do any more by hand. We'll probably just be punching them in on our calculators. So next geometry application, how to tell if 3 points are collinear. Remember in geometry, collinear means they're on the same line. Well, back in the day, we do a lot of calculations with slopes, and it was super time consuming with a determinant. Same thing, write down the 3 ordered pairs, fill in the column with 1s. If it's 0, they're collinear. If it's not 0, it's not collinear. Let's try. Okay, determine whether the points lie on the same line. Okay, so we're going to do the determinant. Doesn't matter the order we write the points. I always get them how they give them to you. We have to know to fill in the third column with the 1s. And we're going to punch this one in our calculator. Punch it in, see what you get. Really more of a typing class today, I feel like. Sound of calculator keys is so soothing. All right, what'd you get for your determinant answer? -6. Correct. Final answer. Are the points collinear? Yes or no? Has to equal what if they're collinear? 0. Sure doesn't equal 0. Not collinear. That's all that is, okay? So you will see too, especially when you get to your review packets and just think about your test. So there's some of this stuff obviously on the calculator part of the test. It will tell you in the directions though. Show enough work, you know, to justify your answer. So meaning you just need what I wrote down for work. You need the setup, punch it in your calculator, the answer, etc. But you are going to have to show like your initial setup just for the record, okay? All right, last thing. Let's do this before we get into Cramer's rule. So fun. Solve the following using Gauss-Jordan elimination. Should we practice another one?
No.
What do you mean no?
We're not doing that.
Johnny, come on. Where's your grit?
We don't need to.
Just because somebody gets 100 on a quiz, now they're all cocky.
Yeah.
All right, let's practice one. Like I said, the quiz scores were really, really amazing. There were still a couple of us with little sketchy things, so let's just do one more. And I'm even going to do it with you. I'm feeling generous today. That is a positive 9. Can't write here. 9, -217. Okay. Do you want a few minutes to try it on your own, or do you want me to just do it with you?
Just do it. This.
Okay. All right. In general, it takes you how many matrices to do it? 4. We've already got the 1. Remember, we work a column at a time. So we like that top left corner 1, we keep it. Okay, easy enough to get this -1 to a 0. All I'm going to do is what with these first 2 rows? Multiply by 1, which I don't even find that worth me writing. Can't we just straight add them? Yeah, so we're just going to add these together. So 1 plus -1, 0. -2 plus 3, oh, like it. 3 plus 1, 9 minus 2. I'm going to have to do a little work for the bottom row to get rid of 2, negative 2. So we're going to times the top by negative 2 and add it to the bottom. Negative 2 plus 2, negative 2 times negative 2, 4, plus negative 5. Negative 3 times 2, negative 6, plus 5. Negative 18, plus 17. Okay. All right, 2 more matrices to go, my friends. So working on the second column. Working on this. We've got our diagonal 1. That blue 1 is what we're going to use to convert the other numbers. So our blue numbers are perfect, so I'm going to fill those in. All right, let's do the negative 2 first. Get rid of negative 2, we need a 2. So I'm multiplying all the blue by 2. We're going to add it to the green. 2 times 0, 0, plus 1. 2 times 1, 2, plus that. 2 times 4, 8. 8 plus 3. 2 times 7, 14. 14 plus 9. Good. And let's do the red negative 1. Now again, we're using the blue row. Super easy. I can just straight add these together. 0 plus 0. 1 plus negative 1. 4 plus negative 1. 7 plus negative 1. And right now, you know that z is 2, because we can divide this by 3. Okay, final calculations. Remember when you thought Gauss-Jordan was so hard and now we're like pros at it? It's no big deal. All right, we're going to change the 4 and then we're going to do the 11. Let's do the 4 first. To get rid of 4, we need a negative 4. So we're using the red numbers. Negative 4 times 0, 0 plus 0. Negative 4 times 0, 0 plus 1. You got it. Negative 4 times 1, negative 4 plus 4. Negative 4 times 2, negative 8 plus 7. Y is negative 1. All right, let's do our last row, the green numbers. To get rid of 11, we need negative 11, so I'm going to change this. So we're going to have 1, 0, 0, of course. And this is the one that really counts. Negative 11 times 2, negative 22, plus 23. So x is 1, y negative 1, z 2. Piece of cake. Okay? And same thing, same deal as like your quiz, which obviously I'm not worried about after how great your quiz scores were. On the no calculator part of the test, there's 2 Gauss-Jordan problems on there by hand, okay? Kind of same as the quiz layout. All right, last thing I'm going to show you with determinants. This is one of those things where it's easy. I promise you it's easy. It's just irritating because it's a little time consuming because you have to do a lot of calculations with determinants. So you can solve a system of equations with determinants. Honestly, would I ever actually do that? Probably not. But just another method, another way to do it. So here we're going to start with just a 2 equation, 2 variable. We are going to do a 3 equation, 3 variable. So the first thing you're going to do, and of course this is difficult because they have all the crazy letters. First thing I'm going to do, it's a lot of calculations. I'm going to do the determinant of the coefficients on the variable. So like A, C, B, D. And if it's a 2 by 2, I mean, I'll probably just do that determinant by hand because that's super easy. And you can see for x and y, that's the denominator. So whatever number I get for that, that's going to be what I'm going to divide by. Okay? Now, to get x and y, here's the irritating part. You're going to take the values that it equals, they're using r and s, and you put those in the x slot. Notice the y's, the b, and the b's. So many crazy letters here. Stay for y. And then when you go to do y, the numbers, let's do green here, the numbers the equation equals r and s go in the y location. And then of course the x variables, the a and the c, they stay. Okay. So looks crazy. I promise you it's super easy. Now when we get to a 3 by 3, like that's just obnoxious because you have so many determinants to calculate. We're going to do that one in our calculator for sure. Okay, so 2 by 2. First thing I'm going to do is just the determinant of the coefficients on the variables. So 2168. Now, 2 by 2 is pretty easy. I think I can just do it mental math quicker than typing it in my calculator, because you're just doing your diagonals. 2 times 8, 1 times 6. All right, so then to figure out x, obviously we're going to do x first. It's going to be over 10. We got to do the top here. I'm going to fill in the over 10 part. Now, to do x, the top determinant, you're going to take -1 and 2 and put those in the first column for x. And the values on y, which are y1s are 6, 8, those stay. And again, 2 by 2 determinant, I can do that one quicker in my head than trying to do it in my stupid calculator, because I'm going to have -8 minus 12. And we're over 10 still. So I'm like, oh, -20 over 10, got it. Now, to me, that's a whole lot of tedious work to get x when I probably, if I had a choice, would just do like elimination or something. But just another way to do it. We're going to do y. So again, you're still dividing by 10, that determinant of the coefficient matrix. Okay, and then to do the top. So this time, the -1 and 2 are going to be the second column. They're going to go where the y values would be. And then the x ones stay. So I'm looking down there at x is 2 and 1. And then I think I can do the 2 by 2 quicker than my calculator, because I'm going to have 2 times 2. 1 times -1, so I end up with 5 over 10, 1/2. So just another way we can solve a system. Is it my favorite way out of all the ways we've done? Probably not. But just another way or another application of determinants. So let me just show you, we're going to do a 3 by 3. We're going to do all those determinants though in our calculators. We're not doing all that stuff by hand. Okay. So first up, write carefully here because you're missing some terms. We're going to do the determinant of just the coefficients. So x, I've got 2, 1, 3. Y, -3, 0, -2. And then z, 4, 6, 0. Okay, punch that guy in your calculator. We're not doing that by hand. And I'm not going to make you type them all, and I'll give you some of the answers today. Because it's just time consuming. Let's at least do this guy. All right, what'd you get for this one? Perfect, RJ. All right, so we're going to do x, and then we'll do, of course, y and z. So I know x, we're going to be over -38. Now, to set up the determinant for x, we're going to take the values that you equal, 1, 0, 5, and those go in the x column. The other numbers stay as is. So the y's stay, and so do the z's, 4, 6, 0. Now, just for the sake of time, I'm not going to make you type in all of these. It's just irritating. I did it earlier, obviously. You get for that one, -78. And then we're over -38. 2 negatives, of course, make a positive. They're both even, so that fraction does reduce. It's kind of gross, but it does reduce down to 39/19. So I just gave you the -78 for the sake of time. Okay. So let's do y next. So of course we're over -38. So this time, the numbers that you equal on the equation 1, 0, 5 go in the middle, the y column. The x's are going to stay. X was 2, 1, 3. And the z's stay, 4, 6, 0. Now again, for the sake of time, I typed that determinant into my calculator. I'm going to look at -22 I got. Two negatives, of course, make a positive. They're both even, so I reduced it down to 11/19. Thank God we don't have to do this one by hand or some of these crazy fractions. All right, last calculations you got to make for z. Of course, we're over -38. So this time the numbers the equation equal, 105, go in the third column, the z column. And the others stay the same. So x 213 and y -30, -2. And of course, I typed that determinant in the calculator earlier, and I got for that one 13 and -38. Now 13's prime, so it didn't reduce obviously or anything. All I did for final answer, we never usually like to keep the negative on the bottom, I just kicked it out front. So I'm going to make it -13/38. So Cramer's rule is simple, the setup, but I will tell you, if we had to actually type in all of the, you have to really type in 1, 2, 3, 4 determinants. It's just time consuming, and like sometimes math is a little on the tedious side, okay? Any questions though on how to set up Cramer's rule? And that is on the calculator part of the test. It's on the calculator part of your homework too. So remember, you've got the homework.